We will now determine the geometry of our compounds. By using the AXE method and the table from our lab manual, we'll be able to determine the molecular and electron geometry. The electron geometry refers to the amount and location of our bonding pairs in our compound. This also helps us determine our molecular geometry. We will now determine the geometry of our CCO4 Lewis structure. Using the AXE method, we can easily determine the structure. A stands for our central atom. X is the amount of atoms that are bonded to the central atom. And E is the amount of lone pairs. So we have A, we have 4 bonding atoms and 0 lone pairs on the central atom. So you don't have to put E0. You don't put that. You just keep it A, X, 4. Now, referring to the chart in our lab manual, we can determine that the molecular geometry is tetrahedral. And our electron geometry would also be tetrahedral. Now remember, on your test, you'll have to memorize the chart because it won't be provided for you. Now we can determine the amount of sigma and pi bonds we have. For each single bond, you have 1 sigma and 0 pi. For each double bond, you have 1 sigma and 1 pi. And for each triple bond, you have 1 sigma and 2 pi. Since we have 4 single bonds, it means we have 4 sigma bonds. That's all there is to it for CCO4. We will now determine the geometry of our carbon dioxide Lewis structure using the AXE method. A, of course, being our central atom, X being the bonding atoms that are bonded to the central atom, and E being the number of lone electron pairs that are bonded to the central atom. Look here, we have A, central atom. We have 2 bonding atoms and 0 lone electron pairs. So you can leave the E off. So your AXE formula would just be AX2, like that. Now referring to your chart in the lab manual, we can determine our molecular geometry is linear, and our electron geometry is also linear. Now we can determine the amount of sigma and pi bonds we have. Of course, we have 2 double bonds, which means we'll have 2 sigma bonds and 2 pi bonds. That's all there is to carbon dioxide. We will now determine the geometry of our ozone molecule using the AXE method. A being our central. We have 2 bonding atoms and 1 lone pair of electrons. Referring back to the chart in our lab manual, you can verify that the molecular geometry will be bent or V-shaped. And our electron geometry would be trigonal planar. Because there are 3 electron bonding zones. We'll now determine how many sigma and pi bonds we have. Notice here we have a double bond, which is 1 sigma and 1 pi. Here we only have a single, which is only 1 sigma, which gives us 2 sigma bonds and 1 pi bond.